Question 1. Question 1 is the integral of x squared. So what we're going to do here is we're going to have x squared, but to make the integral, whatever is in the exponent, we add 1 and we divide it by the same thing, so 2 plus 1. Now we can simplify it to make it x cubed divided by 3, or 1/3 multiplied by x cubed. Now what we can do now is test this by taking the derivative of it, and if we get x squared, then we know that we did it right. So for the derivative, we can keep the 1/3 to the side and ignore it just for now and work on just the x cubed. So it's 1/3 will stay outside, and we know that the derivative is you'll bring the exponent down here and you're going to subtract 1 from the exponent. So we'll have 3x squared. But now the 1/3, the 3x cancel, and we're left with just x squared. So we know that this is the integral of x squared. Okay, question 2, we have the integral of 1 over x squared plus x. So the first step that we're going to do here is we're going to split up the denominator to make it 1 over x multiplied by x plus 1, multiplying it by dx, like always. Now what we're going to do is we're going to split this up into two fractions. So we're going to have 1 over x minus 1 over x plus 1 by using partial fraction decomposition. We're going to multiply it by dx. So now we're going to move up here and we're going to find the integral of 1 over x dx, and then we're also going to find the integral of 1 over x plus 1 multiplied by dx. So from here we know that the integral of 1 over x is just going to be ln x, and then for the second one we can use substitution to solve it. So what we're going to do is we'll ignore this for now and solve it on this side. We're going to set u equal to x plus 1, which will mean du is going to be equal to dx. So what we're going to have now, instead of 1 over x plus 1, we're going to have 1 over u multiplied by du. Now you can see it's the same setup as the 1 over x, so we know it's just going to be ln of u with absolute values. However, now that we have this, we have to substitute back what the u means. So the u is x plus 1. So all we got to do now is make this ln of x plus 1. So now putting it together, we have both parts. So we have ln of x, and then we're going to have minus, because there's still the negative or the minus sign here, minus ln of x plus 1, all with absolute values, and then we have to add a constant which we'll call c. So now the integral of 1 over x squared plus x is ln of the absolute value of x minus ln the absolute value of x plus 1 plus c. Okay, question 3 is the integral of sine squared of x. So to start, what we want to do is rewrite this into something that's a lot more simple to use, which is 1 minus cos 2x divided by 2 multiplied by dx. So now what we can do with this is we can split this up into two different integrals, with factoring out the 1/2, because we can ignore it because it's just a constant, and make this the integral of 1 multiplied by dx, and then we'll subtract 1/2 of the integral of cos of 2x multiplied by dx. So to make this easy, we're just going to start off with the integral of 1 which is just x. So to start, we have just 1/2 of x. Now, what we're going to have to deal with is we're going to have to deal with the integral of cos 2x. I'll bring it up here. So what we want to do with this is we want to set u equal to 2x. We want to set du is equal to 2 multiplied by dx. So what we can do is this will be 1/2 the integral of cos of u multiplied by du. This 1/2 coming from the du equaling 2 dx, because to get dx by itself, you gotta divide du by 2, and that's where the 1/2 comes from. So now it's just an easy integral of cos u, so it's 1/2, and then this will just become sine of u, and the du goes away. So this sine u, we have to implement the sine or the u into the 2x, so we get 1/2 of sine 2x. Okay, so now from here we take the 1/2 x, we can just make this x over 2, and now we can put the both 1/2s together to make 1/4, and we'll put sine 2x in the numerator to give us this equation. Now we could leave it like this, but I want the denominators to match, so I'll multiply the x by 2 to make it 2x over 4 minus sine 2x over 4. And now since they have the same denominator, we can put it all into one equation to make it 2x minus sine 2x, all divided by 4. And then plus our constant c. So for question 4, we're going to do the same question of the integral of sine squared of x, but we're going to use a different method. We're going to use the reduction formula. So the reduction formula, I'll write it up here, for sine nx multiplied by dx is the negative cos x sine to the minus 1 x, all of that divided by n, plus n minus 1 divided by n, the integral of sine n minus 2 x multiplied by dx. So since we have a 2, anytime we see an n here, we're going to just substitute the 2 in. So we're going to have negative cos x, and then sine, this is n minus 1, so 2 minus 1 x divided by 2 plus 2 minus 1 over 2, the integral of sine 2 minus 2 x multiplied by dx. So this will become negative cos x to just sine x divided by 2 plus 1/2, and then sine to the 0, because this will just be 0, is 1. So it's just going to be the integral of 1 multiplied by dx. So this will give us now negative cos x sine x divided by 2 plus the integral of 1, which is just x, and then we put in the 1/2, so we'll get x over 2. So we could leave it like this, but we're going to simplify the cos x sine x to give us negative sine 2x, and since it will be divided by 2 again, it will be divided by 4 plus x over 2. So to make this a little bit easier, what we're going to do is we're going to make it so that it is negative sine x, or sine 2x, plus 2x, all divided by 4. Okay, we have question 5, which is the integral of sine squared x multiplied by cos cubed x multiplied by dx. So what we're going to do to start is we're going to split this cos cubed into a cos and a cos squared. So now we'll have the integral of cos x multiplied by sine squared x multiplied by cos squared x multiplied by dx. So since we know that with our substitution we're going to want to cancel out this cos, we know that our substitution has to involve sine. So we're going to look to see to try to find a way to put this into terms of sine. So what we're going to have is cos x multiplied by sine squared x, and since we can use a couple trig identities here, we can turn our cos squared x into 1 minus sine squared x, because sine squared x plus cos squared x is equal to 1. You bring the sign over, subtract it, and that's what we have there, the 1 minus sine squared x. So now what we can do is we can make it u is equal to sine x, and our du is going to be cosine x multiplied by dx. So what we're going to have here is we're going to have the integral of u squared multiplied by 1 minus u squared multiplied by du. So from here we can put in our u squared into both things in the brackets, and we'll have the integral of u squared minus u to the 4 multiplied by du. Now this is just a simple integration where we can have u cubed divided by 3 minus u to the 5 divided by 5. And now we just substitute sine x back in for the u and we're all done. So we're going to have sine cubed of x divided by 3 minus sine to the power of 5x divided by 5, and then we add our constant at the end, and we're all done.